What's up, guys? Today we are going to be looking at Cal 4 Test 1, reviewing it. So if you have a Cal 4 1 test 1 coming up, maybe this will help you. Where are my markers? Here they are. Alright, so the first question is relating to squeeze theorem to find if the limit exists. And this is something that I have a little bit of difficulty with because it's just broad and like a abstract stroke in the Cal 4 theory. But it's a pretty easy problem. So the limit as x and y is going to 0, 0. So the limit as x and y is going to 0, and should I do this test, or there's a version A and a version B, and I'm deciding which one, but they're pretty much exactly the same except one number is different. Well, actually, no, there's a few things different, but it's kind of hard to tell what the difference is between a squeeze theorem problem, because all you need to do is just show that one is bigger than the other. Or, well, not one's bigger than the other, but one is going to 0. If it's going to 0, then it works. Yeah, I'll just do my test that worked in the past. Okay, to show that the limit exists, we use the squeeze theorem, which is, which one? It doesn't really matter, but I'd like to get it right. G of xy, it's, okay, so g of xy is the lesser of f of xy is lesser than or equal to h of xy. Okay, and this is the squeeze theorem. G of xy is less than or equal to f of xy, which is lesser than or equal to h of xy. So pretty much what you do is you use lesser than or greater than to show that it exists. So let's see. This is the one that I have the most difficulty with. So it's really just difficult for me. I don't, because you have to use greater than or less than, and it's like, how do you know which one to use? I mean, other than just braining it. But whatever. She did it a different way than I did it, but I got full credit, so I don't really know which way to work. Oh man, let me turn on the fan, it's quite hot in here. My brain's working early in the morning, that's why. Like, all the other parts of this test are just real math, it feels like, and this squeeze theorem. Like, I used to be able to do it because it was first introduced in Cal 2, and in Cal 2 you use integrals, so you do a less than or greater than integral, and if they both go to the same number, the one inside goes to the same number. But for this one, you're just making sure that the limit exists. So it's like, we have 2x to the fourth, x fourth plus y to the fourth. Yeah, that's right. So pretty much 0 is 0 is less than, yeah. 0 is less than 2y x to the 4th over x to the 4th plus y to the 4th. And this is like less than 2y. Because the thing on the bottom is such a big number that this just by itself is going to be bigger than 2y. 2y by itself is going to be bigger than all of this. Because, I mean, if you get rid of the x to the 4th, you have y to the 4th over y. So obviously this number is going to be much smaller than a whole number by itself times 2. And as this is 0, the other one's 2 minus 0, well, 2 times 0. I think this is the only, is it the only bit I need to write down? Okay, yeah, wait. So, what I was saying earlier, x to the 4th plus y to the 4th. See, this right here is much smaller, so, which is something that she wrote down as well. So, yeah. So, x to the 4th over x to the 4th plus y to the 4th is less than 1. And by doing that, we can just say that this is bigger than this. Okay, and this is if x, y, and this is if y is greater than -1. This is if y is greater than 1. Yeah, because we have to do another if statement to show that if it's -1, it'll still be bigger or something. Or it'll still go to 0, you know? Yeah. It's greater, it's like, it's this same equation except it's backwards. So if y is less than 1, or sorry, -1, or actually it only needs to be 1 because if it's like 0.5, I mean, shoot, that's small, right? Yeah. Oh no, it's if y is greater than 0. This is something I have a lot of difficulty with. I'm sorry if it's not easy to understand my explanation of it. But, so in this, you turn it around and you get 2y x to the 4th over x to the 4th plus y to the 4th. It's greater than 2y. And then, as this is going to 0, I mean, it's 0. If this is going to 0, it's going to be 0. So this must be 0. And then this, as it's going to 0, is 0. This is definitely, 0. And then this one is 0. And by doing that, we can determine the limit exists, because if it's a 0, if it's not like 0 over 0, which is undeterminate, the limit does exist. So from doing that, we get that the limit of this is equal to 0. Because, I mean, if you were to plug in 0, you'd get 0 over 0, and that doesn't work. Now, there's one other way, which is what I did on my test, and it's y is equal to kx, and then you plug in kx, and what you get is, in the end, what you get is 0 over 1 plus k to the 4th. And that's, is it k to the 4th? Yeah, you factor it out, yeah. So you get, because you get 2xk over 1, because once you do the math, it's really weird. Some really weird stuff. But from that, we determine that the limit is real. And that's problem 1. I hate Squeeze theorem. It's so difficult for me. Because it's like, it's a lot of theory. Well, it's not a lot of theory, it's just a lot of thinking you have to do for one equation. Okay, problem 2, whole lot easier. Should I do this one or should I do this one? Yeah, second derivative. Find f of x, y of f of x, y is equal to e to the x squared minus y squared, that's to the power of that, and then plus natural log of 3x y squared. And when you do that, you get f of x. Now you can do it f of y too. You can do either one first, but I actually did both on my test, which is kind of funny because I mean I had enough time to do it. But pretty much what you get is you should not be looking at it. It should be showing you. So if you take the derivative in respect to x first, you're gonna take it. So it's going to be 2x e to the x squared minus y squared plus, natural log becomes 1 over 3 y squared. No, it's not that. It's actually, it's 3x y squared, because when you take the chain rule of it, you multiply by the inside of the derivative. So it's times 3y squared, right? And then what you get is both of these cancel, and you get 1 over x. And then when you take f of x, y, what you get is, since you're taking in respect to y, it's going to be negative 4xy e to the x squared minus y squared plus 0, because, you know, if you have the derivative of that. But that's the answer, and I know I'm right without even having to look. But yeah, that's the answer. It's a pretty simple problem 2. Problem 1 took me quite a while. I don't think it took me that long in the test to do, but whatever. Okay. So she has 2 classes. One class is a 50-minute class, 1 hour. One class is an hour and 15-minute classes. So in the hour and 15-minute classes, she has 10 problems for you to do, but for our class, she only has 7. So she added the extra ones in the test review, so I'm gonna do those to, you know, wisen my brain up. Okay, this one's nice. So use the chain rule to find dz ds. I'm gonna put a dash through my z so it's differentiable. Okay, so, and what this is equal to, what the chain rule is it's pretty simple. All you have to do is take the derivative, like, okay, so dz over dx, times ds over dx plus dz over dy dy over ds. Oh, I messed that up. Gotta keep the eraser in hand. My brain autocorrects when I'm wrong. dx over ds, because what you had is you have z is equal to, I should have written the equation first, but you have z is equal to 4x minus 3y, and this is to the third power, so it's binomial to the third power, which is really annoying. And then you have x is equal to st squared, and then you have y is equal to s squared t squared, and t to the third, and yeah, you just take the things, multiply them, and then my teacher said you can leave it, you don't have to like multiply it all out, because it's a, you know, when you take the derivative of all this stuff, it's going to be pretty long. So when you take the derivative of a binomial to the power, for some reason you just do chain rule. So much easier that way, so much easier. So it's going to be 4x. Oh, actually, I'm quite hungry, but I wanted to make this video before I ate, which is kind of tough. Let's just do the easier one first. So dx ds, taking it in respect to s, so it's going to be t squared. I'm pretty sure I'm right on that. Yeah, okay. Just making sure I'm doing my partial derivatives right. Okay, so you have 3 times 4x minus 3x squared, and then you have to multiply, oh, it's not 3x, it's y. It's the first time I've done one of these videos. I need to do 2 more today, but I'm gonna eat some first, and then I have to multiply by the derivative in respect to x, so it's just gonna be times 4. So it's gonna be 12 times 4x minus 3y squared. And that is, yeah, it's correct. Okay, now dz over dy, and just the same thing, so 3 times 4x minus 3y squared times negative 3, so it's going to be negative 9, you know, basic stuff, dy over ds. Now, so you can do it in respect to s, or you can do it in respect to t. I don't know if you're going to get the same thing, but I'm pretty sure that's how the theorem works. It's called Green's theorem. No, it's not called Green's theorem. What theorem is it called? Cauchy's? No. Oh man, what theorem is it called? No, Green's theorem is what we just did. It won't take me more than a second to find what theorem it's called. Clairaut's theorem. Okay, that's why I was like Cauchy. Cauchy-Euler is what we do in differential equations, and it's kind of annoying, but yeah, Clairaut's theorem. That's what chain rule is, and Clairaut's theorem isn't chain rule, but it's f of xy is equal to fyx. And those are partial derivatives when I'm saying fyx and fxy. Wait, where's chain rule? Chain rule is this section. It's just a rule. So, you know, they're not going to tell me who made it, but whatever. Yeah, okay, so does that make it equal though? I don't think it does. No, so if you're finding dz dt, it's a different thing than dz ds, apparently. I'm pretty certain about that. Okay, so, and then dy ds is equal to 2s as t to the third. And then what you do is you just plug it back into this original chain rule. And not very easy. I'm gonna take a knee. That'll help. Let's see. Okay, so first off, so I'm not going to simplify, but we get 12 times 4x minus 3y squared, and that's times t squared, and then plus -9, so it's really minus, but 4x minus 3y squared, and then that's times 2s t to the third. And it's kind of hard to see, but yeah, it's not that hard to. Is that right? Okay. So then afterwards, after you do that, after you get that equation, you then substitute in x and y back into the original equation. So what you get is, it's going to take me a second to write this big thing. dz over ds is equal to 12t squared times the binomial of 4st squared plus, or no, minus 3s squared t to the third, and this is squared. Yeah, so this is why she didn't want you to, simplify this, because you have a big equation. 3 bigs. Okay, and minus 9 or minus 18 s t to the third times the same thing, so 4st squared minus 3, right? It's the same thing? Yeah. S squared t to the third squared. And that should be right. Right? Let's see. Made it a little difficult to understand on my version. Let's look at the test version, solution version. Yeah, she didn't even plug in X or Y. I didn't have to do that for you, but you're supposed to. You're supposed to. She says you do it, but she didn't do it on the test answer. So, I'm correct. Yeah, I'm just gonna say I'm correct on that one, because it looks like I am. She says she gives you this equation, and then he says when x and y is equal to st squared, s squared, at to the third, and then that's it. She's just like, yeah, you do that. Okay, and this one wasn't on our test. Number 4, implicit differentially. Yeah, no, this one wasn't on our test. So this one is the one I need to review the most, because it's it's something that wasn't on the test when I took it. I made 100 on this test. Very happy. Oh, gotta make a really good grade on this last exam, because on the last test I had a panic attack because I didn't study at all. And let me tell you, that does not help your grade. But whatever. Okay, dz dy is defined implicitly as a function of x and y by the given equation. Okay, so for implicit differentiation, what you get is you get dz over dy is equal to, what you do is you flip it and then you make it negative. So it's going to be at negative fy over fz, and that's implicit differentiation. What that means conceptually, I have no idea, but we're going to do it. The equation's really long, but whatever. Actually, let me make it bigger. Maybe I can not have to look, not have to step down every time. So f of x, y, and z, right? Yeah. F, y, and z is a big equation. X z to the third minus x y to the third, and then plus sine of yz. That's great. That's wonderful. And we have minus y, natural log of y squared, and then plus why is there a 0? Okay, minus 4, and then that is equal to 0. So negative. Let's just find fy first. So fy in respect to y, what you get is negative 3xy squared plus cosine of, I think you multiply by z actually, right? You multiply by z. Yeah. So it's cosine of yz, but you multiply by z because it's chain rule. You multiply what's inside by the outside. So z cosine of yz, and then minus what? That's just negative 1 over y squared times 2y, and then minus 0 because it's constant. Okay, and then I'm pretty sure that's right. Yeah. And fz, what is fc? 3xz squared, that's 0, plus y cosine of yz, and everything else is 0. So that's it. So go back to this and you plug it in. So negative fy. I was about to do it in my head again. Z cosine of yz minus 2y over y squared. And I could reduce it. Because it's just y over y. It's really just negative 2 over y. But we're gonna worry about that a different day because that's just basic algebra. 3xc squared, not negative, plus y cosine of yz. So the reason why you can't just get rid of the cosine of yz is because this is a different term, this is a different term, so this divisor, the divisor, is applied to each of the different terms separately. So if I really wanted to get rid of that, I would have to show how every term is devised, and I don't want to do that. That's a lot of math. That's a lot of just simplifying, and I don't have to on the test. If your teacher is really nice, you don't have to. But yeah, that's implicit differentiation. Now on to, man, I'm hungry. Now on to 5, which has 2 parts. Find the gradient vector of f, and I'm just gonna write f real quick. F of y is equal to what? Give it. X to the 3rd y plus x squared y squared. So A is find the gradient vector, and B is find the directional derivative of f at point P equals -1. So P is equal to -1, 1, and in the direction of vector U, U's are kind of hard because it's like, you know, what am I even doing? So 2i plus j, and so a directional, the gradient vector is pretty easy. All it is, I don't remember the name of that, but it's backwards sigma or whatever, of fx, comma fy, and so that's the direction, that's the gradient vector, and blah 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 blah. Yeah. So the directional derivative is du. It's not delta. I don't even care about that. Okay. So when it's asking for the du, it's asking for u over the magnitude, which is like something you learn in Cal 3. So pretty much it's just the square root of 5, because it's the x squared plus the y squared plus the z squared, and 4 plus 1 is 5. So it's really just the point we're getting is just, wait, did I do this correctly? She might have given me the points and I did it correctly. Oh. Never mind. I forgot. So let me just find the directional derivative right here. Oh, let's see, fx is 3x squared y plus 2xy squared, and then comma, and then y, so it's x to the 3rd plus 2x squared y. And then to find, it asks us to find the directional derivative at point -1, 1. So you plug in -1, 1 right here, and that's what I was gonna do, or supposed to do. So what you get is x, y, 3 plus -2, so 1, and comma, so -1 to the 3rd is -1, plus 2. So that is equal to -1, 1. Yeah, it's just 1, 1. We all love 1. Wait, it's supposed to be 5. -1. This is -1. This is +3. Did I do it wrong? I did it wrong. She gave me the points, and I did it wrong. This teacher, bro. It's 3 minus 2. but I did 3 plus 2 on my test. So, dude, this teacher is crazy, bro. What in the world? So it's 2 over square root of 5. And then 1 over square root of 5. Right? And then you multiply it times both. Yeah. So then you multiply it by the directional derivative, and that gets you du gradient f. So du gradient f is equal to negative 2 square root of 5, comma 1 over square root of 5. And then, you do dot product? Oh. You're supposed to add those. So there's supposed to be a dot product right here, right? Yeah, why is there not? Whatever. It's gradient f dot u over magnitude, which is equal to negative 2 square root of 5 plus 1 square root of 5. So pretty much what you get in the end is, how did I get negative 2? Am I wrong? No, I'm not wrong. What? She did it wrong? Are you kidding me? Oh, she did it wrong? Because you have 1, 1. And then okay, I think I might have done it wrong. No, actually, I don't think I did it wrong. So it's 1, 1 dot product 1 over 5 square, then 2, 1. What? Yeah, 2, 1 up there plus this times the dot product of this. And then you add it. She's wrong. Because wait. Oh, I get where I'm wrong. Okay. I accidentally used this. I accidentally used this instead of I shouldn't have written it twice. I accidentally used this number instead of this number to do my calculations. So it's not negative 2, it's positive 2. And it's supposed to be 3 over square root of 5. I was like, what? What am I doing? I did it instead of the 1, 1, which is what you get when you plug negative 1, 1 into that. So I plugged in the wrong thing, which is my fault, honestly. I made it confusing for myself. But that is directional, what is that, directional derivatives? Gradient vector and directional derivatives, yeah. Cool. Oh man, I can't wait to eat something. I did it wrong and she gave me the right answer. I'm not complaining. But that's funny. I almost did it right, but I did it wrong, which is, this is the long one? Or, well, this one's extra. Okay, find the maximum rate of change of f at the given point and the direction in which it occurs. Okay. Where's my water? don't have this one, so I'll have to look at the PC. Is equal to x squared plus x e to the x y, and then there's cosine of y, and comma 2, 0. I wrote 3. Yep. Why did they give us 2, 0? I don't think she did the direction. She did the maximum rate of change. Oh, the direction is the point. Oh, that's my bad. Okay, so to find the maximum rate of change and the direction at the given point in which it, or the maximum rate of change at the given point and the direction in which it occurs, the direction is just the point because we substitute 2, 0 in, and then we get a vector, and the vector is the direction because I don't understand how a point is, no, a point is just a singular thing. A vector is a direction and magnitude. So, yeah, that's what it is. That's what it is. Yeah, the magnitude is the square root of both things, the vector squared. So like x, y squared. Okay. Well, this one's quite easy. All you gotta find is the gradient of f is equal to, let's see, okay. Oh yeah, I have to do product rule here. That's a pain, but whatever. Okay, so first off, you get 2x plus y e to the xy cosine of y, comma, and then you have to do product rule, which is so great. E to the xy, that just becomes x to the, oh yeah, it's lefty, right? Plus right to left. Left e to the xy. Cosine is negative sine of y. Plus right d left. So cosine of y times x e to the xy. It's pretty easy. It's just, I'm tired. Whatever. So now you find the gradient of 2, 0. And that is 0, which is great because this is 0. This is xy, xy. This is e to the square. Wait, what? What? Oh, sine of 0 is 0. Yeah, okay. So this just becomes 0. No, it doesn't. No, it doesn't. I'm wrong. It becomes 2. How does it become 2? That's because cosine, this is 1, and this is 2, and then this is e to the 0. Okay. And then this is 0, so it's 4. So when you plug it in from left to right, I'm not explaining that. Y'all do that. Take a screenshot right now. Let me make sure the frame's on point. Yeah, it's good. Just gotta double check things, you know. If I'm really gonna upload this to YouTube, my craziness needs to be in check. Well, so what you get is 4, 2, and that is the direction in which the vector, magnitude, all that happens. And then the maximum rate of change is this plus this. So how do you do that? You add it. So it's 16 plus 4, which equals square root of 20. And I'm not reducing that because I don't care. And you shouldn't either. Square root of 20 is the maximum rate of change. Hooray! Yeah, let me put it in this. And that's magnitude. Booyah. I like Cyborg from Teen Titans. Okay, well, next is linear approximation. This one involves a lot of writing. And they also give you an equation. So I guess I'll write that equation real quick. Such a long equation. Yeah, there's two equations. Oh. There's a linear approximation and there's a quadratic approximation. And they give you, or at least for me, they gave you the equations on the thing. So let me write this down. Actually, I'm very glad I have this paper. Okay. So L, which is linear, equals of x, y. Is equal to f of x to the 0, y. They say not a lot, which I can understand because it kind of looks like a knot, but whatever. F of x of 0, 0 times x plus f of y, 0. I should have written smaller. I'm writing the wrong thing. That's not great. I might have dyslexia. I might genuinely. I'm looking at the wrong thing entirely, and I'm like, because there's two. I'm gonna write this one. It's q of xy, but y'all know that. Gotta write small. F of x of 0, 0, x dash f y 0, 0 times y plus 1/2 times the first thing, which is x squared f x of 0, 0 plus 2xy f of xy of 0, 0 plus y squared f of, yeah, imagine remembering this. Like, I wouldn't say I'm a genius, but that's a long equation. Of 0 x to 0 y naught times x minus x naught, and then plus f of y times x naught y naught y minus y naught. Okay, so that's the linear approximation, and that's the quadratic. And if you can read my writing, that's good, because that's something I'm worried about. I think everybody is, because I was told a lot that my handwriting is very bad. Screenshot that. Pretty much the only person I'm talking to is my brother, because he's probably the only one that's gonna watch a 30-minute video of me doing a review. Honestly, it might be an hour at this point. What am I talking about, bro? I wonder if I can upload. I probably can upload and take a video at the same time. Okay, so what did I did this weird. Oh, I see what I did. Okay, find the linear approximation at 0.21 and the quadratic at 0.00. I'm not writing that. Using Taylor formula at 0, 0 and f of xy. So f of xy the bane of my existence, is equal to sine of 2x minus 3y. Yay! Such an annoying little one. Okay, so first you find f. Yep, it's pretty easy. For the linear approximation, because the first one is f of x naught, y naught. So it equals sine of 4 minus 3, which is sine of 1. And my teacher told me not to reduce these on the test because, you know, it's not pi over 2, it's not blah blah blah, it's not gonna differentiate quietly. This, I'm pretty sure, is like square root of 2. What is this? No, this is pi over 2. So this is 90 degrees. So a bunch of crunch butts. And then I don't need to do that until later. So we're just gonna start with f of x is equal to, don't dox your friends, Elliot. Oh, okay, yeah. Fy. Yeah, so it's pretty simple. Don't need that for this simple part. I wish I'd kept the linear, just the linear up here. But whatever. So it's cosine of x, so 2x minus 3y. And then this one's negative 3 times 2x minus 3y. This is what's coming next. F by y and fx. Fxy. And then you just have to, or I actually need that space. Okay, now x naught, so 2, 1. So 2 times 4 minus 1. So it's, I hate this. I wish it was like a theta, like a real theta. So it's 2 cosine of 1, which I'm pretty sure cosine of 1 is 0 and 2 pi, so it'd be 0, but whatever. 0 degrees, or 360, because it's the start of the circle. Negative 3 cosine of 1. Yeah, that's pretty much it. And that, yes. Okay, so linear approximation. L of x, y is equal to f of x naught. Okay, this is the first one, so sine of 1. So you do the math and then you just plug it in. So f of plus this one, f of x, so 2 cosine of 1. And this is multiplied times x minus x naught, which is x minus 2. And then plus f of y, which is negative 3 cosine of 1. And that's times y minus 1 because it's y minus 1. Oh, that's the linear approximation. And that is correct. Now it's time for some bull. So change it from 2, 1 to 0, 0. 0, 0. Which makes it a little easier, but at the same time it's like really. Okay, so blah blah blah. Let's just erase this. Because it's just, what did I write down? Oh, so for the second one, I just made it 0. Should I have done that? What did she do here? What did she do here? Yeah, well, okay, sine of 0 is just 0, and cosine of 0 is just 1. So that's why it's a little easier to do. Yeah, okay, so doing this, you get 2, -3, and f of xy is equal to, what is f of xy? Negative cosine, so times, so it's time, okay, so it's negative sine, but it's times negative, so it's positive. So it's 6 sine of blah 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 of 0. That's way easier if I just write 0. And these are equal to 0 as well, because it's all going to be sine, and when it's sine of 0 is 0. So these are 0, these are 0. Don't even need to do the math. And this is 0 as well. So the quadratic approximation is f of 0, 0. Now f of 0, 0 is sine, so it's going to be 0. Yep. Okay, now we're going to erase the f of x and the f of y. I'm going to erase this 0.21. Yep. 0, 0, 0, 0, 0. 0, 0, 0, 0, 0. 0 is the best number. What my Algebra 2 teacher taught me. Honestly, I agree. Taylor approximation. So q of xy is equal to 0 plus f of x, so plus 2 times x, so 2x, and then 2x plus f of y plus, well, minus 3 times y. I'm putting parentheses, but honestly, if I were you, I wouldn't. And then you do get 1/2 x squared times 0, so that's 0, plus 2xy times 0, plus y squared times 0. So plus 1/2 times 0. And that's the quadratic. So pretty much what you get is 2x minus 3y. And, you know, when I got this on the test, very happy about that. Okay, that's only 5. I got, oh my gosh. No, that's 7. Okay, that's 7. If I'm going by my test, I only have 7 equations, so it's like, oh, I only have 2 more. But if I'm going by this, I have 3 more. But that's not too bad. Okay. The next one is use the formula. I have to write this stupid formula again. My mind is churning and burning. I have T-minus 22 hours until my Cal 4 exam. I'm not happy about that. Do I have to write this? I don't have to. Okay, let me show y'all. Let me show y'all what the equation is. Oh man, it's quite dark. Really dark. So you get f of x, y, 0, x, blue, 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 minus equals 0. And then to find the equation of the tangent plane and the formula, do this, so you multiply by t. And then this is our starting one. So what we're doing is we're taking fx, fy, fc. Okay. So guys, the reason why it was really dark is because my phone was on 1% and was about to die. which is kind of funny. But pretty much from using that equation, I hope y'all took a screenshot. You have x z to the third minus y squared plus 2xy minus z squared minus 5. This is an hour-long video. Let me just make sure this frame is right. Yeah, you can see everything. Okay, and you take the derivative in respect to x, and what you get is z to the third plus 2y, and then you plug in this point, and you get -3. So you can see where I figured out, oh, my phone is dead, and I'm glad I didn't finish the rest of this problem. But f of y, in respect to y, it's -2y plus 2x, because everything else becomes 0. Fz is 3x z squared minus 2z. And now all I gotta do is plug in, where'd my, there it is. Get this answer sheet, let me get my answer sheet. Okay, so, you know, I heard my voice after rewatching the last bit of it to make sure, and I was like, I need to deepen my voice for sure. Because I'm a man. Okay, so blah 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 blah. Oh, I have 3 more to go, or this is 8. Okay, I have 2 more to go through. Try to make it an hour and 30. That's so long for one video. That's terrible. That's so terrible. Okay, do the math, Elliot. Do the math. So plug in this. So there's no y, so it's just 3 minus 2, so it's just 1. Okay, and then using that equation from earlier, we figure out, actually, you know what, I'm going to do the tangent formulas first. So it's x is equal to x naught, which is 1, minus f of x, so -3, times t. Y is equal to -2 plus 5t, and then z is equal to, what is that? 1 plus t. And that is the tangent equations. Well, okay, so both of these are tangent planes, but this one's like points, and this other one is something else. Okay, so the original is x minus 1, and then plus f of y, so plus 5 times y minus plus 2, because it's minus, and it's minus on the equation, plus 1 times z minus 1. Okay, so both of those are the equations. Oh, equals to 0. Yep. Okay, now that is done. It really took me an hour to do all this. That's crazy, right? Oh, okay. These are the tangent planes. These are the normal lines. Yeah. Okay. I don't want to do the Lagrange multipliers, but I have to. Ugh. Okay, time to erase. Maybe I should be cutting down the time of the video, but honestly, I think when I'm watching it, I'd rather there not be cuts. You know, I'd rather there be a big butt. That's not a great drawing of a butt, but it's a butt. That's a fart. Okay, so f of x, y is equal to y to the third plus x squared plus 3y squared minus 5. And we're looking for the local maximum value, the local minimum value, and the saddle point. How do I do this? Oh, okay. So f of x is equal to 2x. F of y is equal to 3y squared plus 6y. Okay, yeah. And then when you do x is 0, it's 0. And then when you do y is 0, you get what? Why did I have a... Oh. It's because you can factor out y. Yeah. So what you can do right here is you can factor out y. Okay, so you're setting these equal to 0 and then solving. That's what you're supposed to do, not whatever I'm doing. Plus 2 equal to 0. So then what you get is y is equal to 0 and negative 2. That's what I was doing. You know, it might not be the best drawing of a butt, but I like my drawing of a butt. It's funny. Anyway. F of xx, f of y. Wait, no, it's not equal to 0, it's equal to 2. What? Okay, so for some reason, I don't have enough storage on my phone or something, and the video got cut short last time. But we have our function of xy, or yy as I wrote up here, which is kind of funny. Y to the third plus x squared plus 3y squared minus 5. And what we get is we get f of x is equal to 2x. So when you're solving for the x, you get x is equal to 0. F of y is equal to 3y squared plus 6y. You factor out the 3y, you get y plus 2 is equal to 0. So then you get y is equal to 0 and negative 2. And then we get f of xx, which is equal to 2, which is our local min. And then fyy is equal to 6y plus 6. Fxy is equal to 0. And then d is equal to fxx, and this is how you figure out about saddle points. So fxx, fyy, and you get 6y plus 6, and minus f of xy squared, but our f of xy squared in this case is 0, so it's just 0. So plugging in 0, 0 to 2 times x6y plus x, 6 plus 6 is 12. And the only reason why you get a saddle point is if it's below 0, and it's above 0, so it's nothing. It's nothing. So d of 0, negative 2, because that's our other point, is negative 24 plus 12, because it's negative 2, so 12, negative 24, and then plus 12, so you get negative 12, and that's less than 0, so that is our saddle point. Now, I got one more thing to record. Alright guys, that'll be it for today's Cal 4 test review. It's supposed to be staying. I'll see y'all later. Hopefully you enjoyed the video. I'm gonna make some more too, so whatever.